You have a high risk to undergo some error, alright? Because sometimes you add this wrong, sometimes you pick the wrong number, and it's all gone. Just one error post in your matrix, then the whole solution that you will end up with will be just wrong. There's nothing gray in structural engineering. Okay, it's not gray. If you are in construction management, you describe something. Okay, you get some score. Okay, but for us, we have just black and white. Okay, and the possibility to fall into the black scenario is very high, like 95%, and 5% in order to come up with the white one. There's we may not call it research, but people compile the statistic for structural analysis in the US. Okay, so this is the word from my professor back in the US. He taught plastic design in metals. Very famous one, Professor Yura. You can Google his name. He did a lot in the steel construction. But okay, the point is that all the structural analysis performed in the US. All right, let's guess how much was conducted incorrectly in a fraction percentage. 10% incorrect, 20, 30, 40, you name the number. I guess how much? You have no idea. Okay, and when I tell you the number, you'll be shocked, because it is 70% was done incorrectly. So if one get the drawings and calculation and perform the check seriously, you find that okay, there's something wrong. But anyway, that's something wrong might not be so serious, and it was covered by the factor of safety. It was covered by the load factor 1.2, 1.6 for steel, 1.4, 1.7. Okay, this day the concrete is 1.2 and 1.6 also for the new ACI. It has a strength reduction factor of 0.9 for flexure, 0.65 for axial. Okay, so this number, okay, roughly you get 2, right? 1.6 divided by 0.9, 0.85. Okay, roughly you get almost 2. Okay, not exactly 2, but you have the margin for error. And you really don't want to use that, because that margin for error, the overstrength ratio, overstrength factor, was used for just some situation that you don't really want it to happen. Like, okay, you design the apartment building, but maybe one day it was turned into the pub, okay? And okay, there's a lot of people gathering up party in that room, okay? So that will be the situation, that the extreme situation that the overstrength ratio, the load factor was used for. Okay, but it is not initially designed for you to make mistake and make use of that margin. Okay, so that means you have less margin for the overstrength situations in the future. But anyway, many structure is still standing up because of that load factor and strength reduction factor. 70%. That's in the US. Okay, pretty standard, I think pretty good, high standard construction and design. Still 70%. There is something wrong there. You put some number wrong into your matrix, then all things gone wrong. Okay, so we try to minimize that error. So that's why we engage with the computer, make use of its accurate work, okay? So we let the computer do all kinds of this plugging in, setting up, casting up the stiffness matrix combined into the system matrix and run all the calculations inside the computer. So the next part is that you as a user must put something which is totally correct into the computer. Garbage in, garbage out, that's the thing. So if something has gone wrong with your input, then the output you don't expect the right things out. And most of the time, when we throw some number into the computer, it is like the gate to the heaven, right? You feel it's like that. So you throw something into the heaven, and then you expect that whatsoever comes out of the heaven must be a good thing. All right? But it is not correct. You run, okay, you input something into the SAP run analysis, done. No bug, no error, report. And then, okay, I get these numbers, okay, I get this bending moment, I get this shear force. But you input something wrong in there. Maybe it's a human error, okay, some mistake, you did too much structural analysis, you make a really huge model, so there could be something wrong in your model, your structural model. Sometimes your theory, okay, your understanding is not correct, and that leads you to that error. So that the different kind of, you have two kinds of error that is possible. Anyway, we try to minimize that error, at least the error during the procedures of standard structural analysis, okay, casting the equilibrium equation that will be thrown into the computer, and I wish that you understand everything that will be done, that will occur in the computer. So, okay, we've gone through from the first class to the last class in order to let you know, understand the procedure for analysis. I guess at this point of time you understand pretty much, and we are ready to start to think, to tell the computer what to do. All right? But based on your knowledge now, and let's see, okay, how to translate what we understand to the computer language. Which is okay, it's going to be MATLAB. I'm going to show you for this class today. All right? So what you thought that it looks easy in your brain may not be as simple in the computer, but in fact your brain is much smarter than the computer. So that's why we feel like, oh, you just do this, do that. But in order to communicate, to teach the computer to do, yes, it takes some effort. Let me use my computer. Last night in the evening, I had a glass of coffee, 2 glasses of lemon iced tea, 2 glasses of Coke. Okay, coffee for sure, caffeine, right? Coffee, caffeine. Okay, that's how the caffeine word comes, because it's related to coffee. The tea, okay, caffeine. Okay, Pepsi or Coke, okay, lots of caffeine. When I was a student writing the dissertation back 6 years ago, so we write the dissertation for the PhD. In the night, I stay up to 3 to 4 in the morning. I wake up at 8. What keeps me stay up late in the night was Pepsi. Okay, so just a can of Pepsi. Okay, and then I drink. Okay, I can stay up in the night. So actually, we have some caffeine in Pepsi. But last night I had 1 glass coffee, 2 glasses iced tea, 2 glasses Pepsi. Come back home, try to sleep, because the night before the class, every class, you thought that the professor life is easy, but it's not that easy. The night before the class, I try to go to bed no later than 10 o'clock. And then I want to keep my sleeping hours at least 8 hours before the class, right? So from 10 to 6 in the morning, then it's roughly 8 hours. And normally I wake up before 6, 5:30 sometimes, so I try to push up to maybe 9:30. But 8 hours guaranteed to make sure that in the very next day I come to the class, I still can communicate to you and you can understand me. I can come to the class and talk about everything and then walk out of the class and you have no idea what he just talked about. So, okay, to prevent that situation, okay, 4 days a week, Sunday night, Monday night, Tuesday, Wednesday night, 4 nights in a week, I go to bed before 10. So those who send me the email after that time, okay, don't expect me to read. I tried last night, okay, went on to the bed at 9 something, cannot sleep, still cannot sleep. I try everything, cannot, and that took me up to after midnight, so I can fall asleep last night. So today, okay, you may expect something, you may not understand me that well because I cannot maintain that sleeping hour. It's like a pilot. Eh? I think the pilot is under this rule also. Okay, you need to sleep this much before the flight. Just like pilot. So that's why I said, okay, professor life is not that easy. I wish to stay up to do some more work, but oh no, I cannot. I have to go to bed. Okay, right. So it's on? Not yet? I thought I saw the lights. Oh, okay. That is off. And in fact, well, you are in a student's lifetime period. You will learn this soon. If you overstrain your body, for example, if you sleep like 4 hours a day, and then you can maintain that for maybe roughly about 4 or 5 days. Okay, so you have some kind of superhuman power. You can do that, and you will not feel like sleepy during the day. Okay, if very next day you sleep that less and on, you don't feel anything. But at the end of the 5th day, and if you spend time sleeping, you will sleep just like crazy. You sleep day and night. It's like a miracle. Your human body is sometimes very unbelievably strong. Okay. Alright. Then we will make new M5 for the structures. You have the M5 for the beam, for the truss, right? That will be called from this M5. This is like the main engine for structural analysis, also for finite element analysis. This engine is also used. So this one will do all the administration. Okay, we'll talk to many subroutine, many modules, and then put together all modules to work. So we would have structures. Okay, let me draw. Give you one structure. In order to make the computer understand geometry of these structures, you would need to tell the computer these are my node numbers. Okay, so at the node, you assign coordinates to the node, right? You assign text, the member ID, by the way, what would really help you when you have a sleepless night, drink lots of fluids, water, that help a lot because it makes your blood thin, not too viscous. So when the blood is thin, then the circulation is better. It carries more oxygen, so they help dropping oxygen into your brains and that help revitalize your body a bit somehow, and that helps. Drinks a lot and then you walk to the restroom so many times a day, but anyway you don't feel like too sleepy. Okay, so assign the node number and then assign the member. This is what you have to do by your own. Okay, but if you use SAP, then SAP will do all of this for you, but you will understand, okay, how SAP or stat pro things. Okay. So I will first of all assign, there must be the matrix that includes the coordinate of all the joints, right? Because we do skeletal structure, so we want to know where the joints are. Then you set up the x and y coordinate. It's your choice, okay? You want to set it up here or set up there. You end up with the same result for structural analysis. Okay, so set up x, y coordinates. Set up the axis, location, the origins, and then you can say, okay, what are these coordinates? So let me give you some numbers, maybe. Let's make this one 0 and 0. This one was 0, 3. Just like the problem we did, 3.5. 0 and 7. This is what? 6 and 0. 6, 3.5. 6, 7. Okay. So we put this into one core function. My SAP. We have the SAP image, CLC, clear screen, clear all, close all. Okay. A good practice for computer programming you better describe your variables. So for example, xy core means x and y coordinates for nodes. Okay. Today, you still can remember. Tomorrow, maybe you can. But I'm pretty sure next 3 months you cannot, right? So this, for the good programming practice, you write Fortran, you write whatever language, the code for whatever purpose, keep this part there. And then the people in the future, when they want to modify your code or when they want to use your code, they can study, oh, these variables mean this one, so it was supposed to be, the input was supposed to be like this, like that. So keep, you better keep this one. Yes?
So can you put down screen?
Reflecting? Oh. Okay. Better? Still reflect or not? Bigger? This is as big as I can go. So if you wish, you move up. Can you? The font in MATLAB, I cannot enlarge it. sorry. Right, x, y coordinate. What else we need? We need an ELE. Okay, better use the same variables for this class, because when I check your work, one come up with an ELE, one come up with ELEN. Okay, difficult for me. So let us use the same variables name. NELE means the numbers of elements. So you have 10 elements, your NELE will become 10. Okay. NNDE, number of nodes. 15 nodes, 10 nodes, okay, understand. You know the percent sign will make the comment. So this, if you put the percent sign at front and you have something comes after this sign, this thing will not be executed. It is just a comment. Right? What else? We have number of nodes, number of elements, x, y coordinate. We have n map. I will talk about all of that. Node mapping. Okay. You have the drop, mechanical properties of elements.